dot plot. Dot plot showed patterns in data sets, and it's good for small data sets. Obviously, these are numbers, so quantitative data sets. So first step, you'll always find your minimum maximum values. Your second step, you're going to draw a suitable section of the number line. So that's based on your minimum and maximum values. And then you're going to mark dots in at the positions of your data points. And taking a note, if the data points have the same value, you're going to start stacking them on top of each other very neatly so that you can see the pattern. So for example, we have the small data set below, and it's the weights in kgs for 14 adult dogs treated yesterday at a vet. So step 1, we find our minimum and our maximum value, and we just got to look around and find them. Next step would be draw a suitable number portion of the number line. Well, let's take 1 unit smaller than 4, so going from 3, and 1 unit bigger than 10, go up to 11. So there's a suitable portion. And now we're just going to go and mark dots in above each of these values. So the first value is 9, so we'll put a dot above it. Then the next value is an 8, then a 7, then a 4, and then another 9, so we stack it on top of the 9. Then another 8, so we stack that. Then we have a 6 and another 9, so we stack that on top. We have a 7, so now 7 has 2 balls, 2 dots. We got another 9, and we got our 10, got another 8, got another 10. Oh, and we got a little 5 there. So you see we're stacking the balls up. Notice that horizontally we are putting these nicely and neatly in line. Otherwise we're going to distort the pattern which is there. It is sort of a bulk of the balls on the right hand side, so the bulk are around the 8 to 9 kg, so that's sort of weight for the dogs. Fewer and fewer down on the left hand side, so there are a couple that are really light, but the majority of them are sort of round the 8-9 kg mark. Then we have a stem and leaf plot. It, like the dot plot, is also used for quantitative data sets, and again it's going to show patterns or shape of data sets. Always going to step 1, arrange the data in ascending order. Then going to choose a stem and leaf units. So this is going to help us make it key. And last thing is just plot, which can take some time depending on the size of your data set. So let's consider this data set here. I'm not sure how many values there are there, but it goes from value 3 up to 61. So our step 1, putting it in ascending order. That's been done. Next step, we need to find our minimum maximum value and sort of work out based on that our stem and our leaf unit. So notice that our largest value, usually the best way to start, largest value is made up of tens. There are 6 tens and some ones. There is 1 1. So for example, 61 is made up of 6 tens and 1 1. 23 is made up of 2 tens and 3 ones. And notice the smallest value there, 3, is made up of 0 tens and 3 ones. Okay, so 3 can also be expressed in terms of tens and ones. It's no tens and 3 ones. So our stem is going to be making up our tens, and the leaves are going to be giving us the ones. And step 3 is just to draw your stem and leaf plot. So if you do so, this is what it's going to look like. So that first column there, that gives us our stem. So that's the tens column. So we start with 0 tens, 1 tens, 2 tens, 3 tens, 4, 5, 6. So for example, 4 tens means those numbers in there are going to be in the 40s. 2 10s means the numbers in that line are going to be in the 20s. And I'm going to put in there now our key straight away that we found in our step 2. Okay, so the key is telling us that the number 36 would be represented as a 3 on the left hand side of the vertical line and a 6 on the right hand side of the vertical line. So that there is the number 36 according to our key. So then what about this other thing here? Well, if you read 3 on the left hand side of the vertical line, 7 on the right hand side, so it's got a little bit of a gap, and then it's got a 7. Okay, so it happens to have this bit of stuff here we're just going to ignore. So this is going to be 37. So this line here is telling us that we have the number 36 and the number 37. Notice what we have something here, something a bit odd. That doesn't mean we have the value 50 in our data set. Remember how our key is showing this? Value 50 would then be shown as a 5, a vertical line, and a 0, because there are 5 10s and no 1s. But that's not the case here. We don't have 50 in the data set, so we don't put a 0 here. We just leave it blank. Now the importance of this key can come up. Let's suppose we have a data set where we had instead, let's do this. It was done to 1 decimal, 0.3, 0.3, 1.1, 1.2, maybe let's go 2.4. Let's do one more. 2. Oh, that's a point. 2.6. So let's suppose we have those values. Now, I can draw this as a stem and leaf as well. But slightly differently, I could have these ones have no unit 1s, and it has in the first decimal position, could have a 3, we have another one of those. These values here have 1 in the units position, and then could have 1.1, so the first decimal would be a 1. The other value would be 1.2. Okay, and then these two values, they're 2 point something. So you could have 2 in the units position, in the 1's position. First one was 2.4, and then the next one was 2.6. Now if we don't put a key, we might say, look at this, and say 2-4, or 2 line 4, sorry, is 24. But it's not. Okay, it's getting a bit messy here. 2 bar 4 is 2.4. So there the vertical line is actually splitting. It's where our decimal point is going to lie. So that there, just a demonstration how important the key is. You must make it very clear. And now that you've drawn your stem and leaf plot, you can see the pattern nice and clear there. Many values are smaller, and increasingly there are fewer and fewer and fewer with large values. Taking this a step further, we can look at a back-to-back stem and leaf plot. Okay, so this is sort of like an extension. In this here, we're going to compare 2 data sets. So let's look at an example. You're on a diet, but you'll be going out for breakfast with friends. You can choose from 2 restaurants. You've got to decide which of the restaurants you'll choose. So now, obviously, we're assuming that because you're on diet, you're going to want to go to the restaurant where you're most likely to have a breakfast which has least fat in it. Okay, so we're going to work under that assumption. So you're wanting to find the one that you're least likely to get a fattening breakfast. Okay, so the fat content for 14 breakfasts from each of the restaurants is shown on our next slide. So here's the data for our restaurants. Our data has been put in ascending order. So we see that for restaurant 1, the breakfast that had the least fat had 6 grams of fat, and the breakfast that had the most fat had 34 grams of fat. And then for restaurant 2, the breakfast that had the least amount of fat had 26 grams of fat, and the breakfast that had the most fat in it had 46 grams of fat. Now we're going to plot these. Now restaurant 1 is going to look the same. It's going to look normal. Restaurant 2 is going to look a bit odd. It's going to be backwards. Okay, so this is what your final product is going to look like. So restaurant 1, it looks straightforward, and then restaurant 2 looks a bit odd. I'm going to put the key in here straight away. Now we see down the center is our stem. Okay, we're using the same a key or similar key to the previous one. We're not using decimals, we're using tens and ones. Notice your largest value, 4 tens and 6 ones. The smallest value out of all of the data is 6, so that's 0 tens and 6 ones. Okay, so we're not using decimals, we're using tens and ones. So our stem is tens. So for restaurant 1, something like this: 0 tens, 6 ones, just the number 6. Okay, so restaurant 1, a 2, a vertical line, and a 5 would be 25, for example. Okay, now you don't have to worry that there is this other vertical line here. You could, if you wanted, draw a little vertical line there. Okay, so between the 2 vertical lines, you've got the tens, and then on the right-hand side, you've got a 5. That's 25. Now ignore all the leaves for restaurant 1. Okay, then we just keep our stem and our leaves for restaurant 2. Now notice, for restaurant 2, the leaves are still written with the smallest on the left going towards the largest on the right. Okay, so for example, 2, smallest on the left, 4, 4, 5, 5, 6, largest on the right. So we're still reading from left to right, smallest to largest. The smallest values aren't closest. 2 isn't closest to the 4. Okay, so we haven't suddenly swapped the leaves around. Okay, so if you read things, let's go here, because our key actually uses these 2. Notice that the 3 is in the stem, so there's 3 tens. The 9 is in the ones place, so there's 9 ones, so that's 39. And in fact here, if you look at the key, it says a 9, then the vertical bar and a 3 is 39. Okay, so you could actually put a line here saying that if you have a 3 between 2 vertical lines with on its left hand side a 9, that means it's 39. So I think maybe putting in these bars, that might help, okay, with the interpretation. So just a comment, notice the value used here in the key for demonstration is 25. Notice that 25 actually isn't a value in your data set. Your key doesn't have to use values directly from your data set. It's just there for demonstration purposes. So we said for the back-to-back stem and leaf plot, we're going to be able to compare 2 data sets. So looking at the pattern for restaurant 1, very clear. The data seems to peak in the 20s. Okay, and then you look at your restaurant 2, Okay, just visually we can see clearly it's peaking very clearly in a different place. It's peaking towards the 40s. It tends to have larger values. But if you look at the pattern, look at the actual lines, that smooth line that we've put through, that itself doesn't seem to give that much of a clear picture. Other circumstances, it might be even less clear, because for restaurant 2, because of the way we've put our leaves going from smallest to largest, it sort of distorted the image. Actually, a mirror image of the curve if it had been drawn the other way. Okay, so what I mean by okay, so at the top we've got restaurant 1 without restaurant 2 leaves. Okay, so we know that's the normal restaurant 1. Now if we wanted to compare it to restaurant 2, currently that's what restaurant 2 looks like. So now all I need to do, we want to put everything in the normal way, so shift it to the right hand side. So that will move across there. Okay, so notice the leaves didn't shuffle around the order. They're still going from smallest to largest. That will go across. That would go across. Okay, now we can compare the two, one and then the other, so side by side. You see that pattern there? That was the mirror image, okay, of the previous slide. And there's the other one. So we can see though, very clearly in this example, that restaurant 1 tends to have meals, breakfast with less fat. So if you picked a restaurant, if you went to restaurant 1, you're more likely to pick a meal with less fat. And restaurant 2 tends to have fattier breakfasts. So if you pick a breakfast, you're more likely to get a fatty breakfast. So you're on diet, you definitely want to choose restaurant 1.